Welcome all of you to another video of Maths Made Easy. In this video, we are going to take up again integers. I have already done one video in integers. This is my second video in integers. This is from standard 7 syllabus. Okay, so this is a continuation of the first exercise that I had done from integers. In the previous video, I had done addition and subtraction of integers. I had talked about integers and their positions in the number line. Now in this video, I am going to take up the properties of integers. Now you must have heard of properties like commutative property, associative property, closure property, distributive property. Now I am going to explain in detail these properties along with examples, and then I shall be doing few sums from the exercise. That is, this is the second exercise of S Agarwal. So this will cover the second exercise and the third exercise of S Agarwal. Okay, so I am going in sequentially of the with the exercises of S Agarwal, but then if you are taking up any textbook of 7th standard, they will also be following the same sequence. So please watch the video completely. You will have a very clear idea of what I am of the chapter integers. Okay, so let's start. Properties of integers. Properties of integers. Okay. What are the different properties of integers? Let's take up the very first property, which is the closure property. Okay, the closure property of integers. Now what is the closure property of integers? If I have, supposing, if I do 5 plus 4, that is equal to a 9. Now 5 is from integers, from the set of integers, you know that by now. 4 is also from the set of integers and 9 is also. So on adding, whatever I am getting is also from the set of integers. We say that integers are closed under addition, or I can even take this. Let's check this. Plus minus 4. We have done this type of sums. Minus 4, which is a minus 9. Now minus 5 is, or you can say minus 5 is an integer, minus 4 is also an integer, and on adding I get a minus 9, even that is an integer. Okay, then we say that integers are closed on addition. Let me check with subtraction now. 5 minus 4. That's a 1. 1 is also an integer, 5 is an integer, 4 is an integer. So integers are closed on subtraction also. Okay. Now let me check 5 into 4. That is a 20. Here an integer, here also an integer. Result is also an integer. So integers are closed under multiplication also. Okay. So like that, let me check 5 divided by 4. Okay, that is 1.25 or 1/4. Okay, that is not an integer. So integers are not closed under division. Rest they are closed. So how do we say closed? Closed under whatever is the operation. Okay, under addition, or you can say closed under subtraction, closed under multiplication. Means follows closure property. That is it. Okay, now let us take the second property. Okay, what does the second property say about integers? It is the commutative property. It is the commutative property of integers. What is commutative property of integers? Okay, now commutative property of integers says, if supposing I have 5 plus 4, yes, that is a 9, but then 4 plus 5, that is 4 plus 5, that is also a 9, then commutative property are, then integers follow, integers obey, or you can say, yeah, integers obey commutative property of addition. Okay, so on addition they are following, that is, in other words, I can say like this: a plus b is equal to b plus a for all integers. I can try it out for negatives also. Yes, that is a minus 1. 4 minus 5, that is also a minus 1. So it applies for all additions. Okay, so now if I want to check for subtraction, you will see that it is not working. So I shall be doing here only those which integers follow. Okay, so integers follow addition and multiplication for all the properties, but not for division and subtraction. Okay, so I'll just show you how for minus it is not following. See, minus 5 minus 4, that is a minus 9. Now I'll put the 4 first, okay, because here I have subtracted 4. Now 4 minus 5, that is a plus 9. Okay, therefore it is not the same. Hence, when you reverse the position of the two numbers, it is not coming the same in case of subtraction, but it is coming the same in case of addition. Okay, so integers follow commutative property of addition. Okay. Let us talk about the next property, which is the associative property. Associative property. Actually, associative property of addition. Let me write of addition. Now, what is associative property of addition of integers? Let's see. If I write it in algebraic form, it is a plus b plus c is equal to a plus b plus c. Now, what is the difference you see between this? How are these two different? Here, b and c is added first, then the sum is added to a. Here, a and b is added first, and then the sum is added to c. Okay, so this is the difference between the two. So, what I have to do here is, let me take a number 5 plus 7 plus 3. Yeah, that gives me 10, and this is 5 plus 10, which is equal to 15. And then let me take 5 plus 7 plus 3 is 12 plus 3, which is a 15. Therefore, integers follow associative property of addition. Okay, I can try it out with a negative number also. Now, associative, where does the one word come from? We are associating this with this and then with the a. So this to this is associated and then with the c. Let me try with a negative number. 5 plus minus 7 minus 3. Yeah. So that gives me 5 minus 10, which is a minus 5. Yeah. And then now 5 minus 7 minus 3. Okay. So this is a negative 3. So I am just pushing this minus 7, associating it with the 5 first and then the minus 3. Okay. And then what am I getting? This is a minus 2 minus 3, which is again a minus 5. Okay. So I can see that it follows even for negative numbers. You can even make this negative and try. Okay. So a plus b plus c is equal to a plus b plus c. So let me now work out the third rule, the third property. Additive identity. Okay, what is additive identity? Now for additive identity, for any integer a plus 0, okay, is equal to a plus 0 is equal to 0 plus a, which is equal to a. Okay, now here 0 is called the additive identity. 0 is the additive identity. Now remember one thing, here we are talking about integers, so there is a particular additive identity for integers. When we go for natural numbers or whole numbers, they will all have their respective additive identities. So 9 plus 0 is 9. Okay, minus 6 plus 0 is again a minus 6. Therefore, what is the additive identity? Additive identity is that number which, when added to an integer, does not change the value of that integer. That's it. Okay, so this when added to this gives you minus 6 only, this when added to 9 gives you 9 only. So that number which when added to an integer does not change the value of that integer, that is called its additive identity. Okay, now let's take up the next one, which is additive inverse. Okay, additive inverse. What is additive inverse? Now, additive inverse is that number. It's like this. For any integer a, this. If a is an integer, then for any integer a, this is equal to 0. Okay. Then minus a is the additive inverse of this, or minus a plus a is equal to 0. Then a is the additive inverse of minus a. Let me take minus 7 plus what gives us 0. Minus 7 plus what gives us 0? Plus 7. Therefore, 7 is the additive inverse. 7 is the additive inverse of minus 7. Okay. Now 7 plus what is a 0? Plus minus 7 is a 0. Therefore, minus 7 is the additive inverse of minus 7 is the additive inverse of 7. Okay, minus 7 is the additive inverse of 7. So this is the meaning of additive inverse. Okay, then so we have done 5 things. Firstly, we did closure, then we did commutative property, then we did associative property, then we did additive identity, and then we did inverse. Okay, so these are the few properties of integers. Integers follow these properties. Till now we have done commutative on addition, it follows, associative on addition, it follows, closure on addition, it follows. Okay, and it has an identity and it has an inverse. Okay, so we have done that much. Why I am telling it, why I am stressing on addition is, after this I shall also be proving to you that these properties, these 3 are applicable for, and there will be few more new properties also coming, but these 3 are applicable for multiplication also. Okay, they are not applicable for subtraction or division. Okay, few quick questions from this chapter. So here we have few sums. Here minus 13 plus 27 and then a minus 41 outside. Minus 13 has come outside and here 27 plus what? Okay, so it has to be a minus 41. Now which rule is it following? It is following associative property of addition. Okay, associative property of addition. Sometimes they will ask you to write, not only fill in the blanks, also tell which property is it following. Okay, now if you say this is a plus b, this is b plus a, this is commutative property of what? Commutative property of addition. Again, what is this? This has to be a 0. Minus 72 plus what is still minus 72, and this is additive identity. Which is additive identity? 0 is the additive identity. So whenever you talk about associative property, if you just say associative property, you will go wrong, because after this, as I said, I will be teaching multiplication also. So if you just say associative property, it will go wrong. You will have to say associative property of addition, commutative property of addition. Okay. The sum of two numbers is minus 16. If one of them is 53, find the other. Okay. So sum of two numbers is minus 16. If one of them is 53, find the other. So here you are asked to find the other number. One of the numbers is 53. Let me take the other number as x is minus 16. Okay. Now here how to find the number. Now very simply I can tell you this is actually a linear equation. If you know linear equation, I am doing it the linear equation way. So I just take this 53 to the other side. That is only if you know linear equation. Okay. So this is 9. This is minus 69. So the other number is a minus 69. So that is the answer. But then supposing you don't know linear equations, you don't understand what is happening here. So if I just think like this, that one number is sum of two numbers is a 25. If one of the numbers is 15, what is the other number? Then if one of the numbers is 15, don't you subtract it and then you get a 10. Okay, so the other number is 10, isn't it? So 15 plus 10 is a 25. So I had said sum of two numbers is 25, one of the numbers is 15. So whenever a sum comes like this, where it is becoming little confusing, because especially you will not get confused if they give you with positive numbers, but if they give negative numbers like this, you tend to get confused. Okay, so you will have to think that in terms of a very simple positive example, and then take that positive example, solve it in your rough, do exactly what process you did for that in this sum, without being bothered about if this is negative or positive. Here sum is negative, fine, but still from that we are going to subtract the 53. So we are still going to do this, and you know how to do this. Same sign, common sign written, and numbers are added. So you get your answer. So you are doing it without linear equation, just by using your common sense. Okay, here when you did it, you used your common sense, right? Here also, overlooking the fact that it is negative and all, you just follow the same process. So that is it. We'll stop here today at this point. Okay, so we'll stop here today. So that is it. We'll stop here today at this point, and we'll continue from multiplication of integers and properties of multiplication of integers. That is again another set of properties for multiplication of integers I shall be taking up in the very next video. This was from the first exercise only of S Agarwal. Okay, so the next exercise I am going to take up the second exercise of S Agarwal. There are a very good number of very interesting questions. Okay then, so if you have liked my video, do not forget to like, share and subscribe. Also, I would like to hear from you, so please write a comment. It really motivates me when I see your comments. Okay then, bye all of you. Bye then.